bathroom ground fault circuit interrupter, or GFI, branch circuit is required to be dedicated to within that bathroom. This means the circuit serving the bathroom receptacle outlets and any other loads within that bathroom cannot serve outlets or loads in other rooms or other bathrooms. The purpose of this requirement is to minimize the potential for nuisance tripping and to ensure that the GFI protection is effective in the event of a ground fault. GFI protection is required for all 120 volts, 15 amps and 20 amps receptacle outlets installed in bathrooms. This requirement is in place because bathrooms are considered wet locations and the risk of electric shock is higher. When a ground fault occurs, the GFI quickly interrupts the flow of electricity, preventing a dangerous shock. If the bathroom circuit also served outlets in other rooms, a ground fault in one of those other rooms could trip the GFI, shutting off power to the bathroom unexpectedly. This could be a problem if someone was using an electrical appliance in the bathroom at the time, such as a hairdryer or curling iron. By requiring a dedicated circuit, the code ensures that a ground fault in another area of the house will not affect the bathroom circuit. There are some exceptions to the dedicated circuit rule, but they are limited. For example, the bathroom circuit can supply power to equipment within the same bathroom. This might include a light fixture or a ventilation fan. However, the circuit cannot supply power to outlets or equipment in other rooms or other bathrooms. The National Electrical Code, or NEC, provides specific requirements for bathroom GFI protection. These requirements are found in NEC Section 210.11. The NEC is a set of standards that are used throughout the United States to ensure the safe installation of electrical wiring and equipment. The NEC is updated every 3 years, so it is important to consult the latest edition to ensure compliance. When wiring a bathroom GFI circuit, it is important to follow all of the NEC requirements carefully. This includes using the correct wire size, properly grounding the circuit, and installing the GFI receptacle in a readily accessible location. It is also important to test the GFI receptacle regularly to ensure that it is working properly. To test a GFI receptacle, simply press the test button on the receptacle. The receptacle should trip, cutting off power to the circuit. If the receptacle does not trip, it should be replaced immediately. Working with electricity can be dangerous, so it is always best to consult with a qualified electrician if you are not comfortable performing the work yourself. An electrician will be able to ensure that the wiring is done correctly and safely. When planning a bathroom renovation, it is important to consider the electrical requirements. This includes the need for a dedicated GFI circuit. It is also important to make sure that the electrical wiring is up to code and that it is adequate for the intended use. If you are adding new electrical outlets or equipment to the bathroom, you may need to upgrade the electrical service to the house. This may involve increasing the size of the service entrance conductors and the main circuit breaker. It is always best to consult with a qualified electrician to determine the best way to meet your electrical needs. In summary, a bathroom GFI branch circuit must be dedicated to within that bathroom. This means the circuit can only serve outlets and equipment within the bathroom itself. This requirement helps to ensure the safety of occupants by minimizing the risk of electric shock. It is important to follow all of the NEC requirements when wiring a bathroom GFI circuit, and it is always best to consult with a qualified electrician if you are not comfortable performing the work yourself. The dedicated circuit requirement for bathroom GFI circuits is in place for several important reasons. Firstly, it minimizes the risk of nuisance tripping. If the bathroom circuit also served outlets in other rooms, a ground fault in one of those other rooms could trip the GFI, shutting off power to the bathroom unexpectedly. This could be inconvenient and potentially dangerous if someone was using an electrical appliance in the bathroom at the time. Secondly, a dedicated circuit helps to ensure that the GFI protection is effective. If the bathroom circuit was shared with other circuits, the GFI might not be able to detect a ground fault in the bathroom as quickly or effectively. This could increase the risk of electric shock. Thirdly, the dedicated circuit requirement simplifies troubleshooting. If there is a problem with the bathroom circuit, it is easier to isolate the problem if the circuit is not shared with other circuits. This can save time and money in the long run. The NEC also specifies the types of equipment that can be connected to a bathroom GFI circuit. In general, the circuit can only supply power to receptacle outlets and equipment that are located within the bathroom. This includes light fixtures, ventilation fans, and other permanently installed equipment. The circuit cannot be used to supply power to appliances that are not located in the bathroom, such as a television or a computer. There are a few exceptions to this rule. For example, the bathroom circuit can be used to supply power to a towel warmer, provided that the towel warmer is permanently installed in the bathroom and is protected by a GFI. The bathroom circuit can also be used to supply power to a low-voltage lighting system, provided that the lighting system is powered by a transformer that is located outside of the bathroom. When installing a bathroom GFI circuit, it is important to use the correct type of wiring. The wiring must be sized appropriately for the load that it will be carrying, and it must be protected from physical damage. The NEC specifies the types of wiring that are permitted to be used in bathrooms. In general, non-metallic sheathed cable or NM cable is permitted to be used in dry locations, while rigid metal conduit or RMC or electrical metallic tubing or EMT is required to be used in wet locations. Bathrooms are considered wet locations, so RMC or EMT is typically required for the wiring. It is also important to properly ground the bathroom GFI circuit. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electric shock. The NEC specifies the methods that are permitted to be used for grounding electrical circuits. In general, the grounding conductor must be connected to a grounding electrode, such as a ground rod or a metal water pipe. The grounding conductor must also be sized appropriately for the load that it will be carrying. When installing a GFI receptacle in a bathroom, it is important to choose a receptacle that is rated for use in wet locations. These receptacles are designed to withstand moisture and humidity, and they are less likely to corrode or fail. It is also important to install the receptacle in a readily accessible location so that it can be easily tested and reset. The NEC specifies the height at which receptacles must be installed above the floor. In general, receptacles must be installed at least 12 inches above the floor. This helps to prevent them from being damaged by water or other liquids. It is also important to protect the receptacle from physical damage. This can be done by installing it in a recess box or by using a surface-mounted box with a cover. When testing a GFI receptacle, it is important to follow the manufacturer's instructions carefully. The test button is typically located on the front of the receptacle. Pressing the test button should cause the receptacle to trip, cutting off power to the circuit. If the receptacle does not trip, it should be replaced immediately. If the GFI receptacle trips frequently, there may be a problem with the wiring or with an appliance that is connected to the circuit. In this case, it is important to consult with a qualified electrician to troubleshoot the problem. The electrician will be able to identify the cause of the tripping and make the necessary repairs. When working with electricity, it is important to take precautions to protect yourself from electric shock. Always turn off the power to the circuit before working on any electrical wiring or equipment. Use insulated tools and wear rubber gloves. Never work on electrical wiring or equipment when you are wet or standing in water. If you are not comfortable working with electricity, it is always best to consult with a qualified electrician. An electrician will be able to safely and properly install or repair electrical wiring and equipment. The requirements for bathroom GFI circuits are designed to protect people from electric shock. By following these requirements, you can help to ensure the safety of your home and family. If you have any questions about bathroom GFI circuits, it is best to consult with a qualified electrician. They can provide you with the information and guidance you need to ensure that your electrical system is safe and up to code. Understanding the nuances of electrical codes can be challenging, but prioritizing safety is paramount. Remember, when dealing with electricity, if you are unsure, always consult a licensed electrician. They possess the expertise to navigate the complexities of electrical systems and ensure compliance with all applicable regulations.